What'd you do? Your hair is going to be in the camera probably regardless. Alright, everyone get the reading and that you're doing a worksheet. If we don't finish the lesson today, then your worksheet isn't due tomorrow. Last section of chapter 3. If we get done one day, then we have Wednesday, Thursday to review. Friday test. If it takes 2 days, then we only have a Thursday review. Test. Weight. Something, we shouldn't be talking about weight. It's a little taboo, but I'm gonna do it. I'm gonna try. Weight is probably not what you think. What is weight? You may know.
Measurement of Matter Pt1.
Darn it, you're not supposed to copy. Look at the... Ah! Did you guys know when you step on a scale, what you are actually measuring is how much gravity pulls you down? Did you know that? So if you want to feel better about your weight, go up into the mountains in Colorado and step on a scale there. You will weigh less.
Thank goodness.
Depends on what you classify as correct. Because technically, weight can change. Why can weight change? Because I went on a weight loss plan and I lost weight. No, that's not what I mean. Because weight is dependent on gravity, and gravity changes with elevation. If you weighed yourself in outer space, any ideas what you would weigh? Not nothing, but very, very, very little. What was that? To the 10th? I don't know exactly, but it would be very, very small amount. And the reason why is, what do you not have a lot of in outer space? Gravity. Because gravity has to do with your location or your closeness to the center of the earth. If you're a long ways away from the center of the earth, the gravitational force is much less. So this is very important. Weight can change, and when I say weight can change, I don't mean you went and ate a couple burritos and then stepped on the scale and you realize, oh, I weigh 1 more pound. Not what I mean. I mean, weight is dependent on gravity, and gravity can change. If I go up on a mountain, I have less gravity than if I do standing here, because I'm further away from the center of the earth. Gravity is based on how close we are to the center of the earth.
So we would weigh like a lot, or like
Yes. I mean, I don't know about what we would classify as a lot, but you would weigh more. Yeah. Okay? Got it? Weight's dependent upon what? Gravity, and if gravity can change, so can your weight. Weight is a force, and force is measured in newtons. Why in the world do you step on a scale does it say pounds? Yes?
because pounds are more like specific than
No, pounds are just what we're used to. It's what the Americans have decided to use to measure weight. And I will say this, Everett, you're right in a certain sense. You're right that the reason why we use pounds is because we don't weigh a lot more. We weigh the same in newtons, but the number's a lot greater. let's figure out what one of you guys weighs in newtons. Got it? I don't know off the top of my head what the conversion is. Oh, shoot. In newtons. All right, so there it is. Every 1 pound is how many newtons?
4.44822.
Okay, so since we've been doing unit conversions in this chapter, let's do a unit conversion. Who is willing to tell me what they weigh? What do you weigh?
134.
134 pounds? Boy, you're small. Anybody know what I weigh?
No.
Anybody have any idea what I weigh?
No.
Thanks.
185.
I weigh 200 pounds. Do I look like I weigh 200 pounds? Rob must weigh.
Yeah, muscle being
I'm kidding, I haven't looked at it in a very long time. I just was blessed with good genes. Okay, so you said 100 and what?
34.
134 pounds. Let's set up a conversion factor. How about that? What unit would have to go on bottom? Because I gotta cancel it out, yeah? What unit go on top? And we know every 1 pound is 4.448 newtons. Now notice, this isn't a metric unit, so I didn't know where to put the 1 if I wouldn't have known this. Okay? This is kind of where we're getting to in a later, higher level, where you won't just be doing unit conversions with metric units. So let's figure out how many newtons Mr. Mari weighs. Over 500. Close to 600 probably, right?
Holy moly.
What does he weigh?
596 pounds.
You mean newtons? Pounds cancel? Now, does he weigh more?
No.
That's just the same weight, isn't it?
Yeah.
Just different unit, right? Okay. Want to make sure we understood that. Do you next? No, we don't need to waste any more time. Holy cow!
Wait.
I weigh twice you.
Ethan, how much do you weigh? Maybe more.
That's crazy. Now I feel a little bit too big. Okay, why don't you guys put that in?
You'd only be 376. It's like my 300 pound newtons than you. Just for like, yeah, just be in the face.
Guys, keep writing, please. Why can I not find my spring sticks? That's awkward. Oh, I bet you I know where they are. There they are. Yes. This might break my spring scale, but we'll find out. This is what we call a spring scale. This is actually what is the correct way to measure pounds or newtons of force. And remember, we said weight was, that's like slimy. Touch that. I like oil on there.
I want to wash my hands.
Sorry. All right, let's see if I can get this on. This is gonna slip on my hand. Oh. Okay, this is a 500 gram object, and it looks like it measured it pretty well, didn't it? Now, I could take grams and I could convert it to newtons. Now, I'm going something like this, then yeah, it changes things, right? Because I'm applying force. But if I can keep it pretty stable, it's about 500, right? Let's say 500 grams on the weight there. On the weight. On the weight.
Yeah.
That's up. Okay.
Wait,
Okay.
yeah.
Now, we have electronic stuff that does a lot better job of figuring out force than these spring scales. I'm just stating. But it's pretty cool is they can use springs to determine weight because springs have a certain compressibility and expandability. Pretty cool how they used to do it back in the day. Ah, mass! Ah! You guys remember matter, right?
Yeah.
Kind of similar concept here. Matter is anything that has space, or anything that has mass that takes up space. They don't want to touch it.
Yeah, you go ahead and touch it.
Alright, so here's what mass is. Mass and weight a lot of times get used interchangeably. What do I mean when I say interchangeably? Like they're the same, right? Are they the same? They are not the same. Weight can change because it's dependent on what? Gravity. Can you change the amount of matter an object has? I mean, you could chop it in half and you can have half the matter, but that's different. Okay? So what mass is it indicates how much stuff an object is made of, essentially. Okay? Is measured in units of grams, and it has to be measured with a balance, which is what's over there. What a balance does is it compares what you're weighing to some known quantity. We call that a what? Act of comparing an unknown quantity to a known quantity. What do we call that? It's a vocab word from this chapter. Should be the very first one, my guess. Measurement. I am measuring how much mass that object has over there by taking, I know how much this weighs, because I just know. But if I didn't know how much this weighed, I could put it on this scale and compare to something I do know. So let's see. Weigh your phone. Let's see how much your phone. More than, less than 200. Oh, 270. That's pretty darn close. I could get a little crazy. 271. Nope. 270 is about right. 270.3. Did I know the weight of his phone? Not the weight, excuse me. Did I know the mass of his phone? No. Now I do because I compared it to something I do know. We did a measurement right before your eyes, acting comparing an unknown quantity to some known standard quantity. Alright, continuing on. Volume. More vocab. This is we got through all the math stuff for the most part, except for one little other thing we gotta do yet. Yeah. That's where that. Yep. That's enough oil. Is this 100% new? You've never seen the word volume before?
No.
You've never seen the word volume? It's just not new. I kind of think you with that. So if I take like a volume and mass and put them together, what do I get? Matter.
Oh, yeah.
Anything that has mass and takes up space. Would volume be able to determine how much space something takes up?
Yeah.
Would mass identify how much mass it has? Right? Okay? So volume is the amount of space an object takes up. So it's easy to figure out the volume of things that are in nice shapes, but I have a little bit harder time figuring out the volume of this phone, wouldn't I? So I can't really, how do I get length times width times height? Be hard, wouldn't it? Especially with this like doorknob on the back.
Pop.
Pop socket?
Gateway to this.
Why do I need to hold like that?
So you can hold it like this.
Why don't you just hold
My
like
next
this?
be eating my ramen. Are you holding like that? It's Mr. Spock.
Goodness gracious.
Because without it.
Oh, okay. So
It's like a
convenient.
super complicated.
How do you find the temperature on your phone? How do I look up the temperature on your phone? I can't remember else.
I go like this.
You go to the weather app.
Okay.
I asked.
Weather app. Messaging?
You can go like this.
Ooh,
Watch
social
public
networks. I didn't know I could do some.
Hey Siri, what's the weather like?
No, I don't want to update from a demon to a devil itself. Why would I want to do that?
62.
It's
Wow,
that is nice. I
Thanks.
used to have that phone too.
I remember my parents.
Oh, okay.
And then they became uncool.
I remember my dad.
You're only cool if you have
Yeah, I
a
remember
slide
my-
phone,
Slide.
flip phone.
Yeah.
Oh, BlackBerry is the most worthless phones of all time. They like tried to be able to do so much with the most awful interface of doing it ever. Like you had like this. Remember the BlackBerries had like the little like ball on it. You would like run your finger over. It would like scroll.
It was fast.
It's like your modern phone have. It's like the whole screen of a phone underneath it, like the whole keyboard. So the whole phone's like this.
I have a Motorola.
It's like a BlackBerry keyboard.
That's always a great.
It's like the screen on the top and
So you still have the touchscreen on top, but you have the keyboard versus a touch keyboard.
That's terrible.
It's not like a touch screen keyboard. You still touch the keys, but yeah. Huh, interesting. You know, I think a lot of times we forget about volume here, and we gotta go back to fourth grade and remember length times width times height. Or approximately what age were you when you learned how to figure out volume? 5?
14.
Shoot, I mean, my son's gonna learn that next year. Nice. Okay, but notice what is a typical unit you think of when you think of volume? Give me a unit of volume you're familiar with. Milliliters, okay? Cup, ounce, quart, tons. Volume? Never heard of volume. Okay. Actually, he is most accurate because did you know volume is a derived unit of a length measurement? Where the heck is milliliters in length, width, and height? Where the heck is an ounce in length, width, and height? Where the heck is a gallon in length, width, and height? Those units that you guys all said are actually derived units that come from a length measurement. Let me show you what I mean. 1 milliliter, which you're probably familiar with, I hope I get this right, is 1 cubic centimeter. a little cube, a centimeter by centimeter by centimeter. That's what a milliliter is. Another thing, you might want to write this in. 1 milliliter is 1 cubic centimeter. Another way you may at least have heard of it is 1 cc. Everybody, I know you guys all watch Netflix all the time, and you watch those doctor videos, and they say, "Give me a cc stat."
Pieces.
You ever heard that? Yeah, 1 cc is 1 cubic centimeter or a milliliter. That's what the cc represents. Cubic centimeter. It's what doctors and medical people use. I don't know why. They just think that it's way easier to say cc than milliliter or cubic centimeter. So they, you know, if I'm in a hurry, I gotta save this person's life. Give me a cc stat right now. Okay?
CC stat ASAP.
Yes.
All right.
ASAP. I need ASAP.
All right. There you go.
I didn't get that last slide on
Well, what were you doing?
Pop my fingers. Pop his finger. We're lost for a couple moments there.
What didn't you get?
Bottom part.
Must multiply units as well as length. Must multiply units as well as length. So that's why when we did our multiplication, what did we do with the units? You remember when you did sig figs and you multiplied two numbers together that had units? What did you do with those units? You squared them or cubed them depending upon how many times you multiplied them, right? Okay, so that third bullet there is the written version of what I wrote at the top there, that a milliliter is the same as a cc or a cubic centimeter. Okay? Now, the unit that all scientists use as the standard unit for volume is a cubic meter, which I cannot remember if that's a liter. I don't think it's a liter. I think it's like a decaliter or something. I can't remember off the top of my head. Okay? I don't think I need to say anything more about this. It does say the SI unit is too large for most measurements we make, because a meter times a meter times a meter, that's a pretty big volume. A meter sticks this big. That would be a cube like this wide, that high, and that long. If you wanted to measure the volume of this pencil, you probably wouldn't use a cubic meter, would you? Okay? Right. You know. Okay, so what do we do if we've got an object like Shane's phone that isn't nice and easy to measure the length, width, and height of? Okay, it says if an object is irregular. What simply irregular would be? It would be anything that you can't easily use a ruler and measure. For example, would I be able to measure the volume of this marble? Probably not, right? Because it's round. What about if I pulled out a really jagged rock? Would I be able to measure the volume of a rock, of that rock? No, not with a ruler. But does that rock have a certain volume? Absolutely does. So how do we figure out the volume of irregular shaped objects? We use a method known as the water displacement method. Essentially, use a graduate cylinder with an overflow can. I'm not going to use an overflow can, but here is how you would do it. And I will show you how to do it. You weren't done?
Yeah.
Can somebody, what is,
Instead of measuring directly using a graduated cylinder.
and an overflow can? Using graduated cylinder and an overflow can. Sorry, didn't mean to go too fast. We're almost done. We're not going to get through it all, but we'll get through most of it. Would you prefer that I just not give you your worksheet and give it to you tomorrow, or do you want it to see if you can do a few of the questions? What do you want? So here's how you measure an irregular shaped object. And I want to go necessarily show you this before you're done, so I'll let you finish here and then. So what we're going to use to figure out an irregular shaped object is we're going to use the properties of a liquid and its ability to what? Any idea? Flow. Okay? We're going to use water's ability to flow, or a liquid's ability to flow, to help us measure the volume. Because we know liquids fill their container, right? So approximately how many milliliters is that? Just approximately 50, right? If I took this marble and I put it in here, it would displace the water, and the water would surround the marble, giving you a new volume, correct? Okay, now, every time I try this, it splashes. Did I get you?
Yeah.
It wasn't much though. Now look at the volume. Approximately, I think you can. If you look from the bottom of the meniscus, which is, I'll explain what meniscus is later. So you actually look at the lowest part of the middle. So 56. So what's the volume of the marble?
6.
So if I had 50 milliliters to begin with, I added the marble, and now I have 56 milliliters. What's the difference between the two?
6.
We found out that that marble approximately had a volume of 6 milliliters, but I would not have been able to figure that out using a ruler. That is called the water displacement method. Could I do that with any irregular shaped object? I mean, not with this graduated cylinder, but if you had bigger graduated cylinders, what they usually do is they fill it up to like where it's barely breaking, and then that's what this is showing. Is they fill it up so that it's like right up next to where it would overflow, and then you put the rock in, and it all overflows into a graduated cylinder, and then you measure what that is. But you can get an approximation doing this way. I don't have an overflow. Yep.
What if you're trying to use that theory of sponge?
Oh yeah, sponge. Yeah, you're right. That would not work for all things. Okay?
How about lunch?
I think that's it for that. Yep. We are done.
How would you measure the sponge?
I do not know. Sponge, you would probably